EMF induction can also be demonstrated using a coil of wire and a magnet. In this case, the magnet is moved into and out of the coil and observations made on the meter or the galvanometer. In this case, what happens then when magnet is moved into the coil? The observation made is that the pointer moves or deflects in one direction. At the same time, when the magnet is moved out of the coil at a steady speed, the pointer moves in an opposite direction to that when the magnet is moved into the conductor. What about when the magnet is held stationary? When the magnet is held stationary, no deflection of the pointer takes place. When the magnet is held stationary in a stationary coil, the observation made is that no deflection of the pointer is observed, just like when the magnet is held stationary. So holding magnet stationary in a stationary coil is the same as holding the magnet stationary. So no deflection occurs. We can also decide to move the coil instead of the magnet and make observations. When the coil is moved instead of the magnet, similar observations are observed as to when the magnet is moved instead of the coil. So when we move the coil instead of the magnet, the observations made are similar to that of moving the magnet instead of the coil. the pointer deflects depending on the direction in which the coil is moved. What then do we make of these observations? So the explanation behind these observations made. So one, we have noted that EMF is only induced when there is a relative motion between the coil and the magnet. This is because electrons entering a magnetic field are deviated as a result of force whose direction can be determined by Fleming's left-hand rule. The force compels the electrons to move, hence this constitutes a conventional current in the opposite direction. Therefore, whenever there is a relative motion between a magnetic field and a conductor, there is an induced current resulting from the induced EMF. The induced current results from the induced EMF.